Okay, good morning, everyone. In today's presentation, we will discuss about the peer sample t-test. How can we apply the peer sample t-test using SPSS, and like what is the basic overview and just a basic overview about the peer sample t-test. Okay, now come toward the next slide, which is about the overview or like the outline of the class. It is a general overview of the paired sample t-test and the practical demonstration how to do the paired sample t-test or when to decide doing the paired sample t-test. Okay, then the objective of this class is like use like when we use the paired sample t-test. Okay, we use the paired sample t-test for comparing mean of the pair data. Okay, like we have the peer data observing from one group of sample. Okay, like for example, if if we have one sample, one group, for example, if you stroke patients and we want to apply some intervention to these patients, and we want to see whether this intervention have any positive effect or if they have no positive effect. For this reason, we apply, we take the data from the stroke patients and then we apply some intervention. And then after intervention, 1 or 2 months, we also collect the data again. So now we have two data from one sample. So in this situation, we want to compare these two data taken from one sample. So in this situation, we will apply peer sample t-test. Okay, so used for comparing mean of a peer data observing from one group of sample. Same individual are study more than one and different circumstances. But here you see the more than one. More than one doesn't mean more than two. Okay, just only two. More than one mean only two. If it is more than two, like 3 or 4 or 5, then at this situation we will apply the test ANOVA. Okay, we will don't apply the paired sample because the word paired means two. So if there is two observation, like we have two data from one group of sample, and that situation we will apply paired sample t-test. Okay, now this is the assumption about when we applying the pair sample t-test. So these assumptions must be fulfilled. The first one, the dependent variable is continuous, like the data should be in the continuous scale or the ratio scale. The second one is the difference between the post measurement, pre and post measurement should be normally distributed, like the data should be normally distributed. This is the example of research scenario. For example, if when we deciding whether our hypothesis fulfilled for the peer sample t-test, our research question is applicable, like peer sample t-test is eligible for our research question or not. So for this, I will give you some practical example. If your research question is somehow like this, so in that situation you can apply peer sample t-test. For example, is for instance, research question is to compare gait speed and patients with stroke between before and after training. Okay, if you have a stroke patient and you want to you want to get a gait training and you want to see whether the gait training has any good effect or not. So you will take a data before the gait training and then after gait training, then you compare. So in this type of situation, the comparison is made by paired sample t-test. Okay, so and that if as you know that in the research we need null hypothesis and alternate hypothesis to check our claim. So in this situation, our null hypothesis will be for paired sample t-test is there is no increase in gait speed after training and stroke patients. Okay, because null is always no change. Okay, so we see that this is the pre-training and this is the post-training, the mean. So we say that the mean before and after is equal. Okay, there is no change. Okay, but the alternative hypothesis, there is an increasing gait speed after training in the stroke patient. Okay, so like this is before training and this is after training, mu2. So we say the mu1 is not equal to mu2. This type of hypothesis is called non-directional specific. Okay, when there is a non-directional specific, so you mostly use two-tail hypothesis. Okay, now here we see here it is like mu1, before training is less than mu2. So it's mean the mu2 like after training is greater than is like increasing. There is an increasing gait speed after training than before training. So this type of hypothesis, we call it one-tail hypothesis. Okay, so in paired sample, you will see these type of things. Now coming toward the state for rejecting the null hypothesis. Okay, just a normal rule is we all know that if the p-value is less than, okay, it's less than 0.05, then we will, if the p-value that obtained from peer sample t-test by SPSS, if it is less than 0.05, then we reject the null hypothesis and we will accept alternative hypothesis. Okay, then decision and interpretation, which is the final part, which will come in the final slide. Now come to the practical example that we will cover in this class. Okay, now the question is comparison of pain between baseline and post second intervention in the intervention group. Okay, this is like we have two group. One is the control group and one is intervention group. So we don't need the control group, so skip it. We just only take intervention group and we take the baseline values and post second intervention. Okay, we compare the baseline and post second intervention in the intervention group. Okay, this is our example. This is our example, and the hypothesis for this is like the null hypothesis. We say that the baseline value in the intervention group, the baseline value for pain is equal to the post second intervention value. Okay, but the alternative hypothesis, we say that the baseline pain at the baseline is not equal to pain at post second intervention. So like pain at baseline is different from the pain at post second intervention. So this is the second step, where first we have to define your research question, then second is to define your research hypothesis. Okay, the third step is this is all to check your hypothesis by using SPSS. So these are the all steps that you will do stepwise in order to do peer sample t-test on your data. Okay, the first thing is you have to check the normality. So before checking the normality, as we know, we have two groups. We have the control group and we have the intervention group, but we want to check only the normality of intervention group. So for that reason, we have to split file. We have to split file and we will check only the normality of the intervention group. Okay, so that's why we need split file first, then we check the normality, then you split file off. Okay, split file off, then select case. The select case is a compulsory in our situation, because in this situation, because you see our main group is intervention group only. Okay, we don't need the control group, that's why we select case. Okay, then the final is we select the paired sample t-test. Now come toward the practical demonstration of SPSS. This is our SPSS data file. This is the ID, this is the groups, gender, age, weight, and this is the WOMEX at the baseline, WOMEX at first intervention, the second intervention, this is Q angle, then this is the pain. This is our variable of interest for our hypothesis. Okay, pain at baseline, pain at first intervention, and pain at post second intervention. Okay, now our first step is to check the normality of pain at baseline, okay, and post second intervention. Okay, so now to check it, the first step is split file. We come to the data, and then come to split file. This is the split file. Then here you see here we will check the organize output by groups. Okay, organize output by groups, and there first we reset. So I will show you all steps. You are here are analyze all cases, do not create group, but we need groups. So that's why we select organize output by groups and then transfer the groups to here. So then you select OK. And you select, so here you see the split file separated by groups. Okay, now come again to the data. This is our data. Now check the normality. Analyze, descriptive, explore. Okay, check the normality. So we reset it. Now we want the normality of sorry, pain at post second intervention. So numerical rating scale. Here it is numerical rating scale at baseline. So it transfer to the dependent list. And numeric pain rating scale at post second intervention. So transfer it. Then come toward the plots. Then check the normality plots with tests. Okay, then continue. And then press OK. Then SPSS will automatically analyze your data and they will give you these like these statistics, but we don't need the all other statistics. We will just come to our interesting the data we want to check. Okay. Numeric pain rating scale at post second first intervention, but we have to come to post second intervention. This is the post first intervention. Okay, baseline. Okay, so we check normality. This is like numeric pen rate at baseline. So this is the normality table. Okay, numeric pen rate scale at baseline and numeric pen rate scale at post first intervention. Okay, so you see here we will analyze it like this. If we have the chromograph and you have Shapiro-Wilk test. Okay, so if the p value here for the chromograph and Shapiro-Wilk test, if it is greater than 0.05, okay, for both we check if it is greater than 0.05, so it passed the assumption of normality. Okay, so we can say that our data is normally distributed. This is according to the rule of the statistics. So here you see the Shapiro-Wilk test, it is also greater than 0.05, and for both okay, so we can say that our data is normally distributed. Okay, so mostly we rely on chromograph test. Okay, so in this case the data is greater than 0.05, so we assume our data is normally distributed. So we pass the first assumption that our data is normally distributed. Now we can apply the paired sample t-test. Okay, so before applying paired sample t-test, I tell you that we have to split file off. Now come to the split file off. Now here you can reset, and so it will automatically go to analyze all case and do not create group. Okay, so it's automatically come here, then press OK. You press OK. So you see here the SPSS will show split file off. Okay, when the split file off, then the third step is select case. Okay, here we will select case. Sorry. Here you will select, come to the data, then select case. Select case. Then here you see we will reset the data, and all cases, we don't need all cases, we will select here if condition is satisfied. If condition is satisfied, and press OK. Sorry, press F. F, we will transfer the group. Okay, and group we need second, we need intervention group. Okay, so that's why we will define the group is equal to 2, and the intervention group is the second group. So that's why we will transfer, and we need only intervention, because our hypothesis is we want to check the pain at baseline and post second intervention in the intervention group. Okay, that's why we will transfer it, and into the intervention group is equal to 2, then continue. Okay, then press OK. Okay, so now our data is ready to final test. Okay, so it is now come toward the to perform the final pair sample test. We will come to analyze, then come toward the compare mean, then press pair sample t test. Okay, so when it's you select it, you have to come here, and then we need the pair post where this one is numeric pen rating scale baseline, transfer it here, and numeric pen scale at post second intervention. Okay, post second intervention, transfer it here. So this is the baseline numeric pen rating scale, and this is the numeric pen rating scale post second intervention. Okay, if you want to see here, second intervention, we first select this is the baseline, and this is post second intervention. You can select separately, or you can also select like we reset. You can press this baseline and then press control and then press second intervention, and you can transfer both together. Okay, both is okay. Then you can come options, so it's you need to select that, then only press OK. So this is our final pair sample statistics. This is the final table. So here you can just see the normal, the mean, and the mean of the at the baseline and mean post second intervention. This is the number of participants. So we have 41 and 41 in both groups. Okay, this is the standard deviation and standard means. Now this is the paired sample correlation. Okay, this show the correlation between the baseline and post second intervention. You can also analyze it by looking to the significant value. So if the significant value is like it is less than 0.05, so we can assume that there is a positive correlation. Okay, this is the positive correlation, but actually most statisticians say that this is just a weak way of interpreting your data. So that's why you have to come here, the main pair sample, just pair differences. Okay, so for that we will come to this, and here we will come to the significance to tell. Okay, this is our p value, the final p value, the numeric penalty scale at baseline and numeric penalty scale at second intervention. Okay, so we come to the p value. Here we see it is 0.01. Okay, so the p value is less than 0.05. Okay, so if the p value is less than 0.05, so what does it mean? So come again to the presentation. So here I define it the state for ruling when rejecting the null hypothesis. So here you see if the p-value is less than 0.05, so we will reject null hypothesis. Okay, so in our case, we will also reject null hypothesis. So what was our null hypothesis? Come to the null hypothesis. So this is our null hypothesis. Null hypothesis says that the pain at baseline is equal to pain at post-second intervention in the intervention group. So we will reject this. So when we reject this, and so automatically we will accept alternative hypothesis. So what is alternate hypothesis? Alternate hypothesis say that pain at baseline is not equal to pain at post-second intervention. Okay, so it is not equal to pain at post-second intervention. So we'll accept the alternative hypothesis because our p-value is less than 0.05. Or we can also interpret, we can also confirm our interpretation from here. You check, you come to the mean. So here you see the pain at baseline is 5, but here it decreased. Okay, so you can say that the pain at the baseline is greater than the pain at post-second intervention. Or you can, because the p-value is less than 0.05. Or you can also report it like this: the pain at post-second intervention, if you want to interpret it by one tail hypothesis. So you can also interpret like this: the pain at post second intervention, it like the post second intervention is less than left tail hypothesis. So it is less than pain at baseline. Okay, so you can also confirm it from here, or you can also analyze it by one tail or two tail from this mean. Okay, so this is also one way of interpretation, but our main focus will be on this significance value. Okay, now how can we report it? How can we report it into when we write a paper? So how can we write it down into the paper? We can put it like this: the pain between baseline and post-second intervention are different, and the intervention group as the p-value is equal to 0.01. Or we can also write it here: the p-value is p-value is like less than 0.05. Okay, so both are okay. So this is our final slide. So I hope you learn about the peer sample t-tests. So if you still have any question, you can post them in the comment section. Okay. And please, if you are new to the channel, so please subscribe. And still, if you have any question and you want to apply the peer sample t-test for your research, so you can post in the comment section, and I will try to help. Thank you.